right. It's recording again. Cool. Okay, so I don't know if you guys have seen Qiskit before, but let me open up some of the materials. Probably gonna cut a little bit of beginning of this video so we start right when I get started. Okay. Okay, all right, now I've got 3 separate things set up for you guys to see. Okay, let me share my screen and let's get started. Okay, so can everyone see my Google Chrome screen? Give a thumbs up. Yeah, it seems like people can see it. Okay, so Qiskit, IBM Quantum's Qiskit is a programming language. It's actually a library within Python, and it lets you run a whole bunch of quantum circuits from within Python. So let's open up the Qiskit textbook. Qiskit textbook. So you guys get an idea of what it looks like with the Qiskit textbook. All right. So this Qiskit textbook, the way it's written is it's a whole lot of different concepts. And then usually in between all of the explanations, they have these little code widgets. So these code widgets, these are, I don't know how familiar people are with Jupyter Notebook, but there's a Python framework for data science called Jupyter Notebook. And what Jupyter Notebooks look like, let me move this so I can click my tabs. So I'm gonna open, which one is it? It's, oh no, this is the wrong one. Hold up a second. I need to open my other Jupyter Notebook. Should open in a second. Yeah, you guys are getting to see my entire file structure. Okay, Qiskit Fall Fest. All right, so this is Emily's coin example. So you may have seen this if you go to our hype. It's actually open already. This is the quantum coin idea that Emily had. And if you go look at her GitHub, you'll find this IPyNB. This is a IPython notebook. So this is a Jupyter notebook. GitHub displays it really well, but GitHub displays it statically. All of this is just like text that you can look at, but it comes from a Jupyter notebook, which is something that you can actually run. And so this is what a Jupyter notebook looks like. And so if I wanted to, for instance, I'm going to have to run each one of these. So you can Control Enter to run, or you can just hit this run button up here. It's taking a little bit of a second. Let's run this one as well. You can see while it's running, it's got an asterisk. There you go, it's completed. And importing also takes a little bit of time. And now we get to the fun stuff. So here, when we run it, it outputs the quantum circuits that Emily built. And I'm just gonna run all of these so you get to see what it looks like. Now, this one, we can edit this. So right now it says, wire shots 100, that's odd. Every other time I've run this, it's at, oh, I forgot to run this cell, didn't I? Did I forget to run this cell? Oh, I need to rerun them in order, my bad. Give me a second, I'm just demonstrating. There we go, okay. So what this did was it built up a quantum circuit with some gates in it. Here it has the identity gate, it has the Hadamard gate, and it has a measurement. And then afterwards, what it does is it runs it on the quantum simulator. So what this means is it's not running on IBM's actual quantum computers, it's running on your local machine, and it's being simulated classically. And what this coin flip program is supposed to do is it's supposed to simulate a coin flip. So it's random, and you should get about 50-50 zeros and ones. So if we change these, if we rerun this cell, we should get different numbers of zeros and ones because it's random, but it should be about 50-50 every single time. And we can even tell it to run the program 1,000 times, and now it gets pretty close to 50-50. If we wanted to run this on an actual quantum computer, we could change this to be one of the many quantum computers that IBM offers. So let's take a look at some of the quantum computers that you can run things on. All right, so I'll be walking you through how to set up Jupyter Notebook in a second. All right, so there's three different ways that you can run these Qiskit circuits yourself. You can do what I've done here, where I've installed Jupyter Notebook on my local machine, and I'm running everything locally actually on my laptop. Then the other two options, and it looks like it's on the internet here, but if you'll notice, this says localhost. If you're unfamiliar with that, what localhost is it's your computer fooling itself into thinking that it is a web server. So it's not actually going to the internet, it's actually just talking to itself as if it were a server. And so I could have no internet access and localhost would still work. Yeah, so this is just running on my local computer. But then the two other options you have is you can go to IBM Quantum's Quantum Lab, and it looks pretty much exactly the same. It's got a whole bunch of different code blocks separated by some text. And you can run them in the exact same way. You can either press the run button, or you can do Control-Enter or Shift-Enter. So this is the second option. And then the third option is Strangeworks. So this is a startup that's in Austin. And what they do is they connect a whole bunch of different quantum technologies, including IBM Quantum's Qiskit, and they give you a really nice UI, a really nice interface for you to work with. So I'm going to log in real quick and show you what that looks like. So you'd go over to projects, and I've already set up the Quantum Coin project in here. Gathering notebook particles, it's just loading. And there it is. It's exactly the same as before. And I'm going to demonstrate something. It's going to run way faster because this is running on one of Strangeworks servers. So when I run this, oh, wow, it's actually installing stuff. That's because it didn't actually have it installed, I guess. And then I'll run this one. I'm pretty sure you don't need to run these two cells because Strangeworks already installs everything you could ever need. And then see, that was pretty fast. And now all of these future cells are going to be running pretty fast. And there you go. It just ran all the way through the entire circuit. And I can change this to 100 and run it again. And there you have it. It's exactly like the other one. And just to demonstrate, this is how you could run it by clicking run. I don't know why it's jumping around so much. So those are three different options. So I can walk people through how to work with any of these. Probably the easiest one is to get a Strangeworks account. So what you do is you can literally just Google Strangeworks. You can go to strangeworks.com and then you can click Get Started and then you'll sign up. And so you'll answer a couple questions, you'll give a password and username, and then you'll get put right into this portal. Now, how do you create a project? This is probably the part that's scaring you guys the most. So one thing I would recommend is you can just copy the Quantum Coin project and start from there, or you can find one of the many projects from the Qiskit textbook and you can start from there. So for example, if you go to the IBM Quantum Lab, they have a Grover's Search lab. So you click on that, you open it up, and it's got all of this stuff here. You could take this whole file and you could download it to your local machine if you wanted to. I believe, yeah, download. There you go. So let's actually do this. So there you go, it's downloaded. Now, if I go to Strangeworks, if I wanted to create a new project, the button was covered under my face. Project owner, project name, let's call it Grover's Theft. I'm stealing directly from their website. And we're going to create a new project. The way I created the Quantum Coin one was I imported from a Git repository, and then I pasted the GitHub link to Emily's Quantum Coin. So if you look over here and you went to the code here, you could click code, you could click HTTPS, and you can copy this link here and paste it into, which tab was I on? Which tab was I on? Oh yeah, paste it right into here. But I'm not going to do that. I'm going to create a new project, and that it'll boot up exactly everything ready. And then I can add a file, and I can add a file from my computer, I'm pretty sure. Upload file, there it is. And let's upload this IPy notebook file, add it in. I am still recording, right? Yes, I am. Good. Takes a little bit of a second. I'm pretty sure this is a large file. And hacked, we're in. So now this entire file is just copied over into Strangeworks. So yeah, I highly recommend using Strangeworks. I think it's probably the easiest solution. The advantages of the other options are IBM Quantum is directly connected to the Quantum textbook. So you get all of these nice lab files for free. You can open up the Qiskit textbook and open up their demos directly. So all these IPy notebooks, every single research on the IBM Quantum website, you can just open it and start reading up, start running things directly in there. You don't need to upload, download anything. It's all already online. So that's one advantage of using IBM Quantum. One advantage of Strangeworks is it's fast. It's also online, so you don't need to install anything locally, but you do need to upload and download files. Yeah, you can also share and publish. So I'm pretty sure multiple people can be working on the file at the same time. So they can edit it. And then the advantage of having it locally is that you have full control over what packages you're using, what version numbers you're using. So you can go over here and install, instead of Qiskit, you could install a previous version of Qiskit. Or if things aren't going right, you can fix them. But this is a little more involved. Just by a show of hands, which of the three options do you think each of you guys is going to do? And let me stop sharing for a second. Albin Shrestha says no. What was that too? What did I say? The fan. Thank you. Yeah. Strangeworks looks pretty good. I feel like a lot of people are going to be using Strangeworks. Okay, any questions? I feel like I went pretty quickly through all of that. Are there any questions about how to use it? Anything you want to see me do? Would you like me to explain how Qiskit works? A little bit about the code? Did everyone look at Emily's example? Has everyone seen that? How do we commit to GitHub? Okay, yeah, let's do that. That's a good thing to do next. Okay. So back to Chrome, and let's, am I an editor on this? I don't think I am. So let me create a new project. Let me walk you guys through the whole entire process of creating a project. So first of all, you'll need a GitHub. Once you log into GitHub, it's going to look like this. And there's lots of different places, but where does it say plus? Right here, plus, new repository. So you're going to create a new repository. And then your repository name, let's say Qiskit, Qiskit Fall Fest Demo. Okay. And the description, blah. I'm going to delete this right afterwards. You want to make sure it's public because we need to be able to view it. And you want to click add a README file. That'll make things easier for you later. You can add a git ignore, you can choose a license. That's up to you. We don't really care. So then you create a repository. And it's going to just look like this. Pretty simple. You can click on readme.md, and this just has here description, but then you can click edit, and then you can say, this repo does things. And then what you'd do is you'd address those 4 points which we mentioned in the slideshow. So you'd say like, in this project, we used Qiskit to implement a quantum, I don't know, what would be something fun? Wormhole, I don't know. I don't think that would be possible. Yeah, so then you can commit those changes at the bottom. You're going to need to give this a message. So you can say, I would recommend making these commits descriptions a little more descriptive, maybe adding a little more details here. We're not going to be reading through all of your commit history, but it's good for your own team to know exactly what you changed. So now you can commit directly to the main branch, and now you'll see the changes are updated here. And this is what we're going to see. It's the first thing we're going to see when we check out your Git repo. Now, if you wanted to add files and things to your Git repo, what you're going to want to do is you're going to want to clone it locally. So I don't know how familiar everyone is with Git, but the way it works is that there's a remote branch, and the remote branch, you can think of it like the one on the web server. And then there's a local branch that's on your computer. And the local branch is the one you edit, and then you push your changes to the remote branch. And that's when we'll be able to see it, and when all your teammates will be able to see it. So there's multiple ways to do this. Does anybody need me to walk through how to clone a GitHub repository? I need to look at the participants menu to see. Just by a show of hands, there's some people who still have a yes React up. Could you put the yes React down quickly so I know that it's not real? Okay, I think there's one. I'm going to assume that yes React isn't real. Now put a yes React up if you would like me to demonstrate how to clone a GitHub repo. And I'll do that. Okay, so it seems like everyone, oh, okay. So there's at least one person who wants to see how it's cloned. So there's multiple ways. Right now, my SSH isn't working on my Windows machine. So for now, I'll just show how to do it with GitHub Desktop. That might be easier for people who aren't familiar. So you can download GitHub Desktop. You can search up like GitHub Desktop. And people will make fun of you for using this if they're mean, but I use it, so it sucks to be them. Yeah, and you can download it, or for Mac or whatever. And then you can open it. You just click this link, and it'll launch the application on your computer. It'll say, where do you want to get it from, and where do you want to put it? So I'm going to put it right here in my GitHub. This is on my computer. So when I click clone, it's going to do a little bit of work. And then if I were to open my file directory, and hopefully you guys aren't looking too carefully at everything, this is all recorded too. Oh, shoot. I'm only sharing my, thank you so much. I'm only sharing the other thing. Sorry, let me do that all over again. Huge apologies for that. Let me delete it. How do you remove a repository? I'll just delete it in my file system. Give me a second. I'll share my screen in just a moment. Okay, there we go. I'll close this. Okay, so let me share my whole screen. So stop sharing, new share, full screen. And hopefully it works out. You guys can see this file directory over here. Yeah. I need a verbal confirmation. I can't see the participants menu. Can you guys see it?
Yes.
Okay, thank you. All right. So I go over here, I click open with GitHub Desktop. It's going to come up with a pop-up. I click open and clone again. Yeah, so that's because I just cloned it and it was confused. But normally it'll just open it up directly. And yeah, you'll have it open. And then when you go into your file system, you'll notice Qiskit Fall Fest demos here, and you can open up your, oh, it's gonna open it with Caliber. Geez, that's way too much. Does not need to do that. Let's open it with Notepad. There you go. There's the README that we just edited with details about a wormhole. You can edit all the files in here. So you could add a file in here that says, it's a new text file, and it says hello.txt, and inside it says hello. And then over here, it'll show up. It'll be a changed file, and it just automatically, it sees it. And you can say created hello. You commit. So commit just says locally, it's now part of the main branch. It's now locally committed, but it's not updated over here. If I refresh over here, you're not going to see any changes until I push origin. Push to origin, this button up here, it's not going to show up. But now that I've pushed to origin, if I go over here and I refresh, there you go. Hello.txt is there, and it says hello inside. So that's one way to do it. If you'd like to get a little more fancy with it, the arguably better way, where you have more control over what you can do, is to SSH. So I'm going to do this in WSL. Don't worry about what WSL is. Just think of it like a terminal. So I think it's this one. We're going to see if this is the correct Ubuntu. Yeah, okay. So, let's see, GitHub. So I'm inside the GitHub directory. I've got some, oh, instead of typing ls. Yeah, so I have some things that I've already put here. I would, first, you have to do you might not have to do this, but I do. So the where I got this from is SSH GitHub. This one. I'll just, yeah. So this is a link. I can post this in the chat. This is the way I prefer to do things. So you can generate a key. So you'll create a private and public key. Then you're gonna save the key in a file. And you're gonna have to go to your GitHub. You're gonna have to go to your settings, your SSH and GPG keys, and then you add the public key. Right. So that's how you do it. And then afterwards you do eval this, and then you SSH add. So what this is doing is it's starting up an SSH agent, and then this one is adding your key to it. And so your SSH agent will now have the key to go into your GitHub and unlock it and pull stuff out. So let me do SSH add, and then I would go to, keep typing SH instead of this, GitHub key. And then I have to type in my password. Hopefully it doesn't show up. Yeah, there you go. So now I've logged in. Now, if I wanted to, I would go back to Emily's, or no, this is my own demo that I just made. I'd go over here to SSH. I'd copy this. Then over here, I would type git clone, and then you can do a right click to paste in terminal, and then you would hit enter, and it'll clone it in here. Now, if I go ls, it used to be that there was, so ls is listing everything that's in a directory. It used to be that there were just 4 directories here. Now there are 5 directories, and I can change a directory, cd, into Qiskit Fallfest. And then when I look inside it, I can take a look at hello.txt, and there you go. It says hello inside it. But this is working from terminal, and if you're not comfortable with that, you don't have to. You can also just print out files. So, okay. But that's for people comfortable with working in terminal. Also, if you are working on your normal machine, after you do this, you can go into the file directory and you can work with it as a normal file system. It'll just be exactly where you put it. Right. Okay. Are there any more questions? Are there questions about this? I did 2 different ways of doing it. One of them is easier than the other, but this one gives you more control. I went through that really fast. I'm sure there are questions. Any questions about Qiskit then? Does anybody need me to walk them through the coin example that Emily posted, or have you guys read it and do you think you sort of know what she's done there? That's a really good example just to understand how Qiskit works. Any questions? Feel free to type in the chat or unmute. If you do decide to, oh, can you walk through it live? Walk through the, yeah, I'll walk through the coin example. Perfect, yeah. Okay. All right, so let's open the Strangeworks one. That's probably the easiest because it's fast. So here's quantum coin. Boom, there we go, we're in. So I'll go line by line. So pip install Qiskit. What this is doing is, this % is like special special commands. So this is not actually written in Python. This is actually a command line or a command. So this is like running in your shell or your terminal. So it does pip, which is Python's installer. I don't know what the P stands for. Install Qiskit. So it's installing the Qiskit package and it does a whole bunch of work there. Then it does the same thing for Python LaTeX encoding. So that's probably helping you when you want to type out LaTeX. And then matplot. Matplot lets you do these nice little graphs here. So every time it says MPL, it's like, I think that's matplot. Right. And then these are imports. So this is importing from the Qiskit library. It's importing a quantum circuit, quantum register, classical register, basic AER. What is AER again? Shoot, that would need a Google. There's a lot of different things here. State vectors let you see the amplitudes. This is not available when you're using an actual machine because you can't look at quantum state without collapsing it. So this is only useful in the simulator. NumPy is a really useful scientific matrices. It helps with matrices and linear algebra problems. You need to import it because it's used in the background for all of these different things. And then these are all for plotting things. And then I'm not sure what get past does, I'll be honest. Okay. So the first thing it does is it creates a quantum register and a classical register. So you can see that this wire here is quantum and this one is classical. It's Songson is getting an error. Yeah, error is the simulator. You're correct. You're correct. Yeah. We thought, what's your question about we use SSH? Could you clarify on that?
I think he's asking about committing with SSH.
Oh, you want to walk through that? Okay, I'll do that in my office hours. So stick around afterwards, and I'll help you through that. Yeah, there's a lot of nice commands you can run from terminal, so that I can spend some time on. Right. So this creates. So it's just a convention that double lines means classical, and then you create a quantum circuit including the quantum register and also the classical register. So before you start your quantum circuit, you need to define all of the inputs. It needs to know how many qubits it's taking in, how many classical bits it's taking in. And this just draws it out. It's like a print statement. So this one, what it does is it takes the quantum circuit and .i is shorthand for like quantum circuit, .add gate, like identity gate. It's like super shorthand because people like to use identity gates a lot. So this adds the identity gate and it adds it to the 0th wire, the Q0 wire. So the identity gate, what does it do? It does nothing. It's called the identity. It's like multiplying by 1. It literally does nothing. So a wire with nothing on it is the same as the identity. Now H is the Hadamard gate. If anybody attended workshop 2, I drew it out, but I didn't explain it. I never got back to explaining it. But this is a uniquely quantum gate. It transfers you from the 0-1 basis to the plus-minus basis. And I can explain more about that if people are interested in office hours. And the nice thing is that once you do a Hadamard gate to a qubit, it becomes an equal superposition of 0 and 1. This might be the state that people usually imagine in popular science articles. It's this halfway between 0, halfway between 1. So when you measure it, it's got a 50-50 chance of collapsing to 0 or collapsing to 1. And so right here, we add a measurement and we add it from the Q wire, and it goes down to the classical wire. So this is, it's saying measure Q0 and then store the result in C0, or rather let it continue through C0. And then this finally picks a backend, and yes, whoever said it in the chat is right. AIR is the simulator. So this gets the backend that it's gonna be run on. This backend could be a simulator, it could be an actual quantum machine. If it's an actual quantum machine, you have to do a little more work. I would suggest going to the Qiskit reference, and you can take a look at how that's exactly done. You have to queue up a job, and then it goes through your internet connection. It runs it, and then it'll come back with the result. And then this is the execute function. It just takes your quantum circuit, it takes your backend, it takes how many times you want to run it, and then this dot result get counts. This is just pulling information out of what execute returns. And then you just plot the counts. So here, if I change shots to 100, oh, I have to run all of the cells. I didn't run all of the cells. So I can do a cell run all. And it'll take a little bit of time, but you can see it's working through each one by one. And yeah, you guys have seen me run it before. Did that help with understanding? I think the hardest part probably to understand is like what it means to actually run it, and then also what a Hadamard gate is, because if you haven't seen that before. Yeah. Songson is getting an error. Could not find a version that satisfies the requirement. Qiskit. Oh, Ubuntu WSL2. Yeah. Yeah. So if you're trying to do things locally, you're going to have a little bit of a tough time. So here's what I would recommend. Instead of doing pip install Qiskit directly, which should theoretically work, but WSL sometimes has some weird things. Sometimes it needs you to download a wheel, which is like Python's version of a package, like the file. Usually it goes to the internet, it gets the wheel, and then it installs it. But sometimes you have to download the wheel and then you can install it. That's a WHL file. So you can find a Qiskit wheel, it's huge. It's like a bunch of megabytes. Or alternatively, I think this is the better option, is you can install Jupyter Notebook. And the way to install Jupyter Notebook, don't just install Jupyter Notebook, install Anaconda. This is Anaconda. It includes Jupyter Notebook, NumPy, a whole bunch of really useful data science tools. And this looks huge, but downloading it once is worth it. Like once you have it, it'll come in handy a lot of times. So yeah, you can download this, follow the installation instructions, and then afterwards, when you finally like open it up, sorry, that's the wrong one. It'll look like this. You can click the Jupyter Notebook thing. It'll open up Jupyter Notebook, and there you go. You'll be inside Jupyter Notebook, and you can open all your funny little files and start working on it. Yeah, and if you have more questions, you can come to office hours, you can share your screen, and I can like debug your machine directly if you'd like. Okay, so I think I'm gonna end the IDE setup here. And now this just becomes office hours. I'm gonna stop recording and then restart so we get 2 separate recordings.